know that we can make a change in magnetic flux through a coil, and change in magnetic flux induces an EMF, induces a current. We know this from section 1. And how can we change the magnetic flux? According to the equation of magnetic flux, there are 3 methods for changing magnetic flux through a coil. One of them is changing magnetic field strength. First one. A current can be induced in a circuit in a coil by 3 ways. Changing magnetic field intensity by changing the magnetic field strength. Second, area. So hold the loop, push it into magnetic field, take it out, push into magnetic field, take it out. So by this way you can change magnetic flux as well. So second method is that. Third method, change angle, orientation of the loop with respect to magnetic field. How can we change the angle? By rotating the loop inside a magnetic field. Third method. Third method is practical than other methods. Why? Because in other methods you should change the magnetic field. How? Move bar magnet farther, closer, farther, closer, farther, closer. You need a very big space. Second method, pull a loop into out, into out, into out. Again, you need a very huge space for motion. But third method, rotate it. Are you moving back and forth, right and up? No. Just rotate it inside a magnetic field. This is practical method. All the generators out there uses the third method. Rotate the loop, rotate the coil inside a magnetic field. So even when you are rotating the coil inside a magnetic field, magnetic flux is continuously changing. Continuously. As you are rotating the loop, magnetic flux continuously changes. Continuously changing magnetic flux in this EMF. We get a continuous EMF. That's why it is the third method is the practical method for inducing EMF. Which one is the practical way for generating electrical energy? A, changing the magnetic field strength.
Yes.
B, moving the circuit loop in and out. C, changing the orientation of the loop with respect to magnetic field. D, none of them.
C.
Which one?
C.
C. This is this practical way of generating electrical energy. Third one. So when we started chapter 6, I told you that chapter 5 we give electric current to a conductor, and conductor applied a force, conductor start moving. In chapter 5, section 3, we converted electrical energy to mechanical energy. But 6.1, we put the conductor inside a magnetic field, we got electric current. In 6.1, we converted mechanical energy to electrical energy. So these devices, generators, are the devices which converts mechanical energy to electrical energy. We get electrical energy from this generator out there. This is Mr. Exam question. Devices that convert mechanical energy to electrical energy are called generators. But how can we rotate the loop inside a magnetic field? Are we going to rotate with our hand? Will we go and rotate with your hand? We should find a way for rotating the loop inside a magnetic field. Huh? We should find some way. It will be easy, it will be practical. Not your hand. So, there are 2 methods explained in your book. One of them is using waterfall. Second one is using coal and natural gas burning plant. In Dukan you have in fact one of them, dams. Those are called hydroelectric plants. Hydroelectric plants in the Dukan. What is hydroelectric plant? You are going to cut the river. You are going to block the water flow. You are going to block it. When you block it, what happens to the water? It starts to rise, eh? Accumulates, water accumulates. After that, you open a gate, just at the bottom of this and the barrier, or this is the gate. From gate, you let water to flow. Because water is raised so much, this water flows from this gate with a great speed. So the great kinetic edge. But I have to make something rotating. After that, I have to attach that thing to the coil. Coil will start rotating. That thing is called turbine. I am going to use a turbine. This is turbine. So what is turbine? Turbine has some arms, or called blades or leaves. When water is flowing towards these blades of this turbine, strikes to turbine's blade. If water strikes to turbine's blade, it applies a force to the turbine's blade. A force is applied. A force is applied at a distance from the axis of rotation. This is axis of rotation. If a force is applied to some distance from axis of rotation, this force produces torque. Yes, this force produces torque. And torque causes object to rotate. That's why this turbine will start rotating by this torque. Because water strikes the blades of the turbine, applies a force. This force produces a torque about this axis of rotation. And turbine starts to rotate by the help of this flowing water. This turbine is attached to the coil of the generator. As turbine rotates, coils of the generator also rotate. This is this generator. So as coils of the generator rotating, we induce a EMF. We got electrical energy. This is the system how in Dukan electrical energy is produced. You open a gate, let water to flow. This water is flowing with a great speed, with a great kinetic energy, great mechanical energy, and strikes the blades of the turbine, and this strike causes some force. This force produces a torque about axis of rotation of the turbine. Torque causes the turbine to start rotation. As turbine is rotating, because turbine is attached to the coils of the generator, coils of the generator also rotates inside the magnetic field. One method is this. Second method is using coal or natural gas burning plant. Also, we need a turbine here. This is turbine. But this turbine is a little different than the structure of this one. It is similar to children holding across the wind and causing that leaves to rotate in the wind. Similar that way. You are going to make a wind. But wind you cannot control always. This time we will produce a steam from water. We will produce a steam from water. There are pipes. You see these pipes? Here is cold water is coming. Cold water. But this water is heated by coal or natural gas. You are going to burn the coal, you are going to burn the natural gas, and you are going to convert this water to steam, because if enough energy, enough heat is given to water, it becomes a steam. Steam is starting to blow just like a wind. Steam is starting to blow just like a wind. And as it is blowing towards these blades of the turbine, turbine starts to rotate. Of course, this turbine is attached to coil of the generator inside this generator. So coil is also starting to rotate. As coil rotates, magnetic flux changes. If magnetic flux changes, there's a induced current in the generator. Turbine's rotational motion must be transferred to the coils of the generator. As turbine is rotating, coils of the generator also rotates. Turbine's rotator motion is transferred to the coils of the generator. Coil starts rotating together with the turbine in a magnetic field. As it's rotating inside a magnetic field, magnetic flux changes according to equation. Which equation? A times B times cosine theta. As coil rotates with constant rotational speed, rotational speed, maybe first time you heard this, angular speed. Rotational speed means angular speed, omega. So, constant rotational speed means omega is constant. Every generator is rotate with constant angular speed. In here, in your house or wherever it is, All they are rotating with a constant angular speed. As they rotate with constant angular speed, angle between the normal of the coil and the magnetic field regularly changes. Why we use the angle between the normal of the coil and magnetic field? Because this angle, theta is defined that way. So magnetic flux, when we are defining magnetic flux, we'll get the angle between magnetic field lines and normal of the surface, normal of the loop, not loop itself. Maybe we should go back to the title 5.1, definition of the magnetic flux. Theta is the angle between the normal of the loop and magnetic field lines. We are going to get this angle. And we know from chapter 1, section 1, omega is equal to delta theta over delta t. Cross product, delta theta is equal to omega times delta t. Okay, this is for some certain interval. Yeah, time, for example, question was like this for first 5 seconds, next 2 seconds, delta t. But in a generator, there is no interval. Always rotating. We don't have such an interval. That's why we are going to remove these deltas. We will get equation. Theta is equal to omega times t. Theta is equal to omega times t. Instead of theta, what am I going to write? Omega t. Then magnetic flux equation will change to phi is equal to A times B times cosine omega t. In here there are 3 constants. Area of the loop is constant. You don't change the area of the loop for a generator. Magnetic field, constant. Omega, constant. What is changing here?
Delta t.
Time is changing. And time changes, as time changes, magnetic flux also changes. Which means as time goes, magnetic flux continuously changing. So, the steady change in the angle causes a change in magnetic flux and induce an EMF in the coil. But we should able to write an equation for induced EMF. We can write it. When we derive the magnetic flux in respect to time, we will get an equation. This is the equation what we get. This is equation. This equation is depends on time as well. It's a function of time. It's a function of time, which is BAN omega sine omega t. One thing you should be careful is this. Magnetic flux equation is a cosine equation. It's a cosine function. But induced EMF equation is a sine function. Sine function and cosine function differentiate as one of them is maximum, the other one is 0. For example, 0 when angle is 0, cosine 0 is 1. It's maximum. Cosine function is maximum. But sine 0 is 0. That's why sine is 0. As cosine gets maximum value, sine function gets 0. When 90 degree, angle is 90 degree, cosine 90 is 0, but sine 90, 1. At 90 degree, sine is maximum, but cosine is 0. Yani, in general, as cosine gets maximum value, sine function is 0. As sine gets maximum value, cosine function is 0. What does it mean? As magnetic flux is maximum, which is cosine function, sine function is 0. Yani induced EMF is 0. As magnetic flux is 0, induced EMF gets maximum value. Mathematically, it tells you that, this fact.
Teacher, so E is directly proportional with the change of magnetic
Yes, change, not magnetic flux. That's the point. Very good. This point is very good point. And every sine function has a graph. Every sine function is a graph. So, if induced EMF is a sine function, it has sine graph. And you know this sine graph? Yes. This is sine graph. EMF of a generator is changing just like this. Yes, it is a changing current. From 0 to the positive maximum, to 0 to the negative maximum, 0 to positive maximum, and so on. It's changing as a sine function. That's why this equation describes sinusoidal variation. What does sinusoidal mean? Changes as a sine function. Sinusoidal variation of EMF with respect to time. As time passes, induced EMF is changing as a sine function, which is called sinusoidal variation of induced EMF with respect to time. Every sine function has a maximum value. For example, sine theta, sine 90 is maximum one. It changes between positive 1 and negative 1. So at 90 degrees, it is positive 1. At 270 degrees, it is negative 1. So the function is changing between these two maximum values, between positive 1 and negative 1, just like this pattern. Induced EMF is also changing as a sine function. Induced EMF also must have a maximum value. So what is maximum value of this EMF? What is written in here? This is maximum value. In sine function, there is just written 1, because y is equal to sine theta, there is 1. That is why it's changing between positive 1 and negative 1. But in here, what is written in front of sine theta? BA and omega. So induced EMF of a generator changes between these two maximum values, positive BA and omega and negative BA and omega. So then it will change between these two maximum values, positive BA and omega, negative BA and omega. Between these two values, it will change as a sine graph. As we check the sine graph, we will observe that this graph is changing in magnitude, as you see it from 0 to maximum, then decreases and becomes 0. Then start to increase in opposite direction, and becomes again maximum but in opposite direction, and decreases again and becomes 0. So magnitude of the induced EMF is continuously changing. Magnitude of the induced current continues to change, and one of them is this. Second, look at the direction. Initially positive, then negative. Then positive again, then negative again. So which means direction of induced current, direction of induced EMF also changes. This change in current in physics is called alternating current. And alternating A put in here, current C put in there, so it's AC. AC is representing alternating current. And this alternating current is so fast changing, so fast, you cannot even see that it is 0. Now in here there is a light. This light sometimes becomes 0. Electric current 0, light is off. It's becoming off in here. It's becoming off in here, off in here. Do you see off when there is no light? No. Why? Because it is fast, so fast changing. In 1 second, 50 times. So in 1 second, this alternating current changes 50 times, which is called its frequency. So the alternating induced current undergoes one full cycle of change in direction 50 times each second, which defines the frequency of this alternating current, 50. And there are 50 cycles. 1 cycle, 2 cycles, 3 cycles, 4 cycles. In 1 second, there are 50 cycles. And each cycle is produced while the loop is rotating once. 1 rotation produces 1 cycle. Second rotation produces 2 cycles. 3 rotations produces 3 cycles. Then can you tell me the outside generator completes how many rotations in 1 second? 50. 50 rotations. Got it? 1 second is this. When you open and close your eyes once, that generator out there completes 50 rotations. 50 rotations. Imagine how fast it is rotating. It is rotating 50 times in 1 second, which is defining the frequency of alternating current. Okay? Then we can define frequency in terms of cycles. Yes. Each wave corresponds to 1 cycle. There are 50 cycles in 1 second, and also loop of the generator rotates 50 times in 1 second. It also defines frequency of a generator. Number of rotations of the generator and how many cycles are there in 1 second. Both are defining frequency of alternating current. And as I said, there is a maximum value for induced EMF, maximum value. As a usual sine equation, EMF equation also has a maximum value. Remember, we said that it's changing between two maximum values, positive Barnow and negative Barnow. So Barnow is the maximum value. This is maximum EMF of the generator. Maximum EMF of a generator is calculated by B, A, and omega. B is the magnetic field intensity of the coil of the generator. A is the area of the coil. N is number of turns, number of loops of the coil. Omega, angular speed of the coil. But in this section, two more names you are going to read about omega. Rotational speed and also angular frequency. These three are defined in omega. This one you know from chapter 1. Omega is angular speed. Angular speed about rotation. Rotational speed is also omega. And also angular frequency is also omega. Not frequency, angular frequency. So I can calculate angular frequency and omega by using the equation we studied in chapter 1. What was the equation? Omega is equal to delta theta divided by delta t. Tell me now. I said you that generator's coil rotates inside a magnetic field. Time for one rotation, which is time for one cycle, it's called, what is it called? In chapter 3 we learned. Time for one rotation, one cycle. It is period. Instead of delta t, I am going to write period capital T. Tell me, what is angular displacement for one rotation?
2 pi.
2 pi. Instead of delta theta, write 2 pi. 2 pi over t is the angular speed or angular frequency or rotational speed of the generator. What if I write instead of 1 over t? What can I write instead of 1 over t?
Frequency.
Now we got this equation. Omega is equal to 2 pi f. In the questions, they will not give omega to you. Instead, they will give f. If f is given, multiply it by 2 pi, you will get its omega. 2 pi f. Okay, now let's do this exercise. It's one of the exam question. Which of the following would not increase? Would not increase. What does not increase mean? Decrease. Yani not increase means decrease.
What?
Which of the following would decrease the EMF produced by the generator? First, rotating the generator coil faster, yani increasing omega. If omega increases, then this EMF increases proportionally. This is not the answer what we expect. We want to decrease. B, increasing the strength of the generator's magnet. Yani increasing B. If B increases, again, induced EMF proportionally increases. So this is not the answer again. And C, increasing the number of turns. N is increasing. If N increases, EMF also increases. Last one, reducing. What does reducing mean? Decrease. Reducing the cross-section area. If area is decreased, of course, induced EMF must decrease. So not increase means decrease. Correct answer is D. Then, can we say that induced EMF is proportional to B? Yes. Is it proportional to area of the loop? Yes. Proportional to number of turns of the loop? Yes. Proportional how quickly you rotate two loops? Yes. Four quantities determine, as you see, maximum induced EMF, B, A, and omega, yani MBA or Barnow. MBA. Mine is MBA, yours is Barnow. Okay, which one you like, use it, okay? Now, about this title, in this section, we have only 3 problems we will solve. 2 are about this maximum EMF. I will solve just one of them. First one is easy. You will solve the first one on your own. I will solve the second one. Both are sectional questions. A generator coil has 25 turns. 25 turns. This is
N.
N. Let's record it. N is 25. Go on. A cross-section area. This coil has a cross-section area of 26 centimeters squared. This is area, but centimeters squared is not a SI unit. We have to convert it into meters squared by multiplying 10 to the power of negative 4. Don't forget. Area is 36 times 10 to the power of negative 4 meters squared. So we always convert centimeters squared to meters squared by multiplying 10 to the power of negative 4. The maximum EMF developed in the generator is 2.8 volt. E max. E max is given. 2.8 volt. E max is equal to 2.8 volts. At frequency of 60 Hertz. This is F. F is 60. What is the strength of the magnetic field in which the coil rotates? What is the strength of the magnetic field? Yani calculate P. So we are going to use maximum EMF equation. Banu. Okay. So maximum EMF is B, A, and omega. What we are going to calculate? We are going to calculate B. So we have to leave B alone by dividing A and omega. Divide both sides A and omega. A and omega. Both sides of the equation must be divided by A and omega. Simplify A, simplify N, simplify omega. So B is equal to E max divided by A times N times omega. Omega is not given directly, but I know how to calculate it. 2 pi f. Omega is 2 pi f. So instead of omega, I will write 2 pi f. All are given. E max is given, A is given, N is given, F is given. Write and calculate. So how much is E max? 2.8 volt divided by. How much is area? 36 times 10 to the power negative 4. 36 times 10 to the power of negative 4. How much is number of turns? 25. 2 pi, we know from chapter 1, 6.28, directly write it, 6.28. And F, how much is F? 60. Close the bracket. And then, when you use the calculator, the result is going to be 0.083 Tesla. This is a mystery question. But choices can be given as millitesla as well. How can we convert Tesla to millitesla? By multiplying 1000 or 10 to the power of 3. So I can convert this Tesla to millitesla by multiplying 10 to the power of 3, positive 3. Millitesla to Tesla, negative 3. But Tesla to millitesla, positive 3. So, result is going to be 83 milli from millitesla to Tesla 10 to the power of negative 3. Tesla to millitesla 10 to the power of positive 3.